Hello, this is Mrs. Scarple, and in this video I'm going to go through the process of dividing using long division for dividing polynomials. On this screen here we have the steps we're going to take. On the following screen we will be determining if x minus 1 is a factor of x cubed minus 3x squared minus 13x plus 15 using the long division process. So the first step we're going to take is we're going to write the problem as a long division. I've already taken the time to do that for us. And then you're going to ask yourself, what do I have to take times x to get x cubed? And we'll write our answer above the term that would be a like term with it. Once we multiply, or once we write that number, we'll multiply that item by the factor x minus 1, or the binomial x minus 1, and write it below the dividend. So the dividend is going to be this cubic polynomial that will be written inside that long division symbol. And then we'll have to subtract. Now we'll need to be careful that we're subtracting each term, and I'll show you how I make sure that happens every time I do it. And they talk about here, you might want to change the signs and add. And then we repeat those steps until we have something remaining that is less than x minus 1. So here's that problem. We have the x cubed minus 3x squared minus 13x plus 15. And what we want to ask ourselves first is, what do I have to take times x? What do I have to take times x to get x cubed? Well, hopefully you're thinking, well, that's going to be x squared. When I take x squared times x, I have x cubed. When I take x squared times negative 1, I have negative 1x squared. So we found what we take times x to get x cubed. We've multiplied the x squared with each of these terms. Now it's time for that subtraction step. And what I do is I multiply every term by negative 1 essentially, or as they had said on the previous screen, to change the signs of every term and add. So you'll see that the x cubes will cancel, and then we just need to combine negative 3x squared with positive 1x squared. And that is negative 2x squared. Minus, we bring down the 13x. And we start the process over. What do I take times x to get negative 2x squared? Well, we're going to need a negative 2 and an x, because x times x gives us that x squared. So now I multiply negative 2x with x. That's negative 2x squared. I multiply negative 2x with negative 1, and that's plus 2x. And now I do that subtraction piece, which causes these signs to change, or these values to change to the opposite. The 2x squared will cancel out, and we now have negative 15x, and we bring down the plus 15. And we ask ourselves again, what do we take times x to get negative 15x? That's going to be a negative 15. So negative 15 times x is negative 15x. Negative 15 times negative 1 gives us a positive 1, or positive 15, excuse me. We go through the subtraction piece, so that changes the signs, and this time everything cancels out. We don't have a remainder. Now, something that you will be asked to do is to write multiplication statements after completing the division. So the multiplication statement is going to be the divisor, the x minus 1, times our quotient, our result. So x minus 1 times x squared minus 2x minus 15. And I should add the word statement here. So let's try another example. Here we have 2x plus 3 going into 2x cubed plus 7x squared plus 2x plus 9. So begin by asking yourself, what do I take times 2x to get 2x cubed? Hopefully you recognize that all we need to multiply by is an x squared. If I take x squared times 2x, that's 2x cubed. And if I take x squared times 3, that's plus 3x squared. Now we're ready to do the subtraction. Remember, that changes the signs. And the x cubed terms will cancel out. 7x squared minus 3x squared is 4x squared. And bring down plus 2x. What do I take times 2x to get 4x squared? Well, I need a 2 because 2 times 2 is 4, and I need an x because x times x is x squared. So 2x times 2x is 4x squared. 2x times 3 is 6x, and then we subtract. The x squared terms cancel out. 2x minus 6x is negative 4x plus 9, because we have this plus 9 to bring down. So now, what do I take times 2x to get negative 4x? That's going to be a negative 2. Negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6. And now when we subtract, we change our signs, they both become positive. The x terms cancel, and we're left with 9 plus 6 is 15. I don't have anything more to bring down. So this is what we call our remainder. And we can write it as the remainder of 15. Now there's two different ways when you have a remainder that you can write the multiplication statement. And you will be asked to write both of them when there's a remainder in your assignment. They both will start with the 2x plus 3. They will both have x squared plus 2x minus 2. And the first method, if I just want to include that remainder, I'll close the parentheses after the minus 2. I'll close the parentheses after that trinomial and add 15. If my remainder were negative, I would write a minus 15. So that's 1. I'll call it multiplication statement A. The other way, again, is the 2x plus 3. And we have the x squared. Let me not make these parentheses overlapping. So we will have 2x plus 3 times x squared plus 2x minus 2, but instead of closing the parentheses, I'm going to write it as 15 over that divisor of 2x plus 3. So if you think of it as, how do I write a mixed number when I can't divide something evenly? I'm just going to do this off to the side over here. So for example, if I have 11 divided by 3, I can think of that as 11 over 3, or even as 3 into 11. Either way works. I'm just going to continue with the long division here. 3 goes into 11 only 2 times, or excuse me, only 3 times. 3 times 3 is 9. And then we need to do the subtraction, and we are left with 2 extras. So as a mixed number, this becomes 3 and 2/3, or like 3 plus 2/3. So that's what's happening here with this 15 over 2x plus 3. We're just taking that remainder and attaching it as a plus, 15 over the 2x plus 3. Again, if the 15 were negative, we would make this a minus, and then 15 over 2x plus 3. And that concludes the video on long division of polynomials and writing their multiplication statements.